This is from last year's third exam, verbatim. But what I will do is we'll skip the first one. I'm sure that you were able to write the balanced equation for the formation of ammonia gas from nitrogen and hydrogen. I already wrote it earlier today. Obviously, on the exam, the trick here was to make sure people remembered to write these as diatomic gases. Good. Go ahead and answer the next two pieces. So one of those is, given the enthalpy for this reaction has a positive value, okay? That forward reaction, N2 plus 3H2 is going to give you 2 NH3. Has a positive delta H, and thinking about only the enthalpic term, what would an increase in temperature in your reaction vessel do to the equilibrium constant? Would it make it less positive, more positive, or keep it constant? And explain your choice. And then on the bottom, it's going back to Le Chatelier. Apart from changing the reaction temperature, what could you do to the reaction vessel in order to favor product formation? You don't really have to maybe explain in detail, because this isn't the exam, but please answer those two parts.
Higher equation. Because can we see that there's more heat in the reactions? Because like we take this heat to from the product.
The way you could think about it is yes. In order to make these from the product, you would have to put in heat to get them. Yes, you're trying to get back to current, exactly. Yeah, I wouldn't necessarily say like these have heat right now, like I wouldn't phrase it that way, which I think is why I got more confused, but to make this you would have to put in heat. Exactly, the sign flips on that would sound endothermic. Yep. Who thinks they've answered the first part? Who's ready to say it's less positive, more positive, or constant? More. Alright, who says KEQ stays the same? Who says it gets bigger or more positive? It's most of the hands. Who says it gets smaller? Okay, great. It does get more positive, it gets bigger. One way to think about it is with Van Hoff, okay? This is 1 over T. So actually, as we raise T on this equation, we're going this way along the line, depending on the change in enthalpy. But we were told change in enthalpy was a positive number, right? We were told it's greater than 0, so our slope is not, the negative of a negative. Negative of positive, it has this negative slope. It will look like this. We can use the Van Hoff exactly as we've drawn it, and as we move this way with temperature, we're expecting natural log of KEQ to get bigger, so KEQ would also be getting bigger. The other way to think about it is simply with Le Chatelier, okay? If this equation is endothermic, we think of heat as a reactant. We have to put heat in order for the reaction to proceed forward. So if we raise the temperature and we put in heat, okay, we're going to shift towards the products, right? We're putting in more of that reactant. On the reactant side, we want to keep going towards the products to keep it balanced. So again, this is the verbatim answer key. Kaplan says if you increase temperature, it'll increase the reactants, and therefore, according to Le Chatelier, you'll shift right towards products. KEQ is products over reactants. So as you're shifting the concentration towards more products, KEQ is getting bigger. Okay. One could also describe this relationship using Van Hoff. It's natural log of KEQ and the inverse relationship of 1 over T. Makes KEQ get bigger when delta H is positive. What was the answer to the bottom part? What could you do to shift it towards the products? And other than raising temperature, which was one thing that would shift you this way, what could you do to your reaction vessel to shift it towards the right? Alex?
Decrease your volume,
Perfect. Decrease your volume. Why does that work?
because there are less moles of gas on the product side, so if you have a smaller volume, the amount of, you're gonna wanna make more space.
Great.
Using your number.
So if you decrease the volume of the vessel, you'll increase the pressure. Okay? Pressure is related to how frequently these molecules are actually hitting the walls of the vessel. If you have fewer molecules, okay? Here, we have 4 moles of things floating around, okay? But this side only has 2. We will shift to the product to combat that increase in pressure. This was one that was, I think I had to go back and give points back because we decided how mean were we gonna be about what could you do to the vessel. People said like you could change the pressure and they're like, but that's not the vessel itself. You could only change the volume of the vessel. And I was like, oh my God, I'm so sorry I wrote this. Okay.